In this problem, we need to show that the nth term of an AP is given by p plus q minus n, whenever the pth term equals q and the qth term is equals to p. So let's begin. We will first consider the first term. Let the first term be represented by lowercase a and the common difference be represented by lowercase d. So here we'll start with the first condition, that the pth term equals q. The pth term means if we have a p, that this will be given by the first term a1 plus n minus 1 times d. This is the general formula. So here a1 is given by our first term a, the n will be our p, so the p minus 1 times the common difference d. So this is the pth term, and it's given that this value is equals to q. So we have q equals to a plus p minus 1 time multiplied to d. We're going to label this as equation number 1. Then it's given here that the qth term, so this will be equals to, so here we have a plus q minus 1 times d, and it's given here that the qth term is equals to p. So that means we have p equals to a plus q minus 1 times the common difference d, and we're going to label this as equation number 2. Now we have to show that the nth term is given by p plus q minus n. So let's begin by finding that we know the nth term, that this is going to be given by the first term plus n minus 1 times the common difference d. So our goal would be to find out the value of the first term and the common difference in terms of p and q. So what we'll do, we'll begin with our equation number 1 and 2. So we'll subtract equation number 1 from equation number 2. So this is going to give us, so here we'll have p minus q, so this will be equals to q minus 1 times d minus p minus 1 times d. So this will be equals to, so we have q minus 1 minus p plus 1 multiplied to d. So this is p minus q. So the negative 1 and positive 1 cancels out. So we have p minus q, which will be equals to q minus p times d, or simply d will be equals to p minus q divided by q minus p. Now if we take negative as the common factor in the numerator, so we have negative times q minus p divided by q minus p, which leaves us the value of negative 1. So that means we have obtained the value of our common difference, so that's negative 1. Now our goal will be to find out the first term. So we can start with any one of the equation, 1 or 2. So let's consider equation number 2. The 2 here is p equals to a plus q minus 1 times the common difference d. Now just now we obtained that the common difference has a value of negative 1. So that means we have p equals to a minus q minus 1. So we can transpose negative of q minus 1 to the left hand side. So we have p plus q minus 1 will equals to a. So here we have also obtained the value of the first term in terms of p and q, that's p plus q minus 1. And now that we have the value of the common difference and the value of the first term, so what we'll do, we'll replace this in place of the nth term, such that we have the nth term given by, so in place of a, we have p plus q minus 1 plus n minus 1 times the common difference, which is negative 1. So let's simplify this. So it's going to give us p plus q minus 1. So we have negative 1 multiplied to n minus 1, so that will be negative n plus 1. The negative 1, positive 1 cancels out, and this gives us the value p plus q minus n. Hence, we have successfully shown that the nth term is given by p plus q minus n whenever we have the pth term, and the pth term given by q, and the qth term is given by p.